Welcome back. I know this looks a bit messy, but I wanted to put it all on one page so as to make life easier for everybody. This is the solution to the donkey and the field problem, where the donkey is inside the field. And over here on the top right hand side you can see the original problem. All the way from his teeth back to the pin on the edge of the field is R, and it's just to be long enough for the donkey to eat exactly half the area of the field. So the first thing we just want to work out is what's our field's area. As you should remember, the field was given 1 unit. So over here, top left, area is pi r squared, so it's pi by 1 squared, which is pi. The complete area is pi, so we want this guy to eat half a pi. Okay? Now, the area that he gets to eat is composed of 3 separate areas. The first one here, area 1, is a segment of a pi, and it's of radius 1, and the angle we're taking to be 2 thetas. So it's half the angle by the radius, where the angle is expressed in radians. So we're saying area 1 has a value of theta. The second area is quite similar to it, this one here that we're looking at, the red one. Now this time we decided to name the angle on the outside as a single one, so it's just beta, it's not 2 betas, and there's a reason for it, you'll see it in a minute. And half the angle by the radius is the size of this piece of pi, so it's half beta, and the radius this time is the length of the rope, so it's half beta r squared. Now then, if we added both of those together, we would have too much, because we would have double accounted for this piece here, this diamond shape. So we've got to go and work out what this diamond shape is, what area it is. Now if you look at the triangle that I have just below it here, it's looking at one half of it, the upper half, and we can see that the radius of the field is 1, so that side is 1. But you can also see that the base is 1. And because we have an angle theta in here, we know from basic trigonometry that this piece here is going to be cos theta. The vertical bit is obviously going to be sine theta, so the height of this triangle is sine theta, and the overall base length is 1. So that one triangle is going to be a half base perpendicular height, so it's half sine theta. And as we can see from the diamond shape we have here, we actually have 2 of those, so this piece that has to get taken away is going to be sine theta. Now, while we have an expression for the overall area now, which is area 1 plus area 2 minus this diamond area, we have unfortunately got 3 variables. We have theta, beta and r. So we want to now start to reduce them. Over here, this is reminding you of a basic theorem that you would have learnt by the time you were 15, certainly, where when 2 radii are produced to the edge of a circle, and lines are drawn from that then to any point on the circumference of the circle, such as the 2 red ones, look at them, there and there, what we know is that the angle here, the beta, has a relationship with this overall angle here. This one here subtended at the center is twice it. And in our naming structure so far, this is 2 thetas. So we know that 2 of the betas and 2 thetas will equal to 2 pi. So beta is theta minus, is pi minus theta. So we can replace beta. The next thing we need to know is what r is. And again, we just come back to this diagram down here, the triangle, and we can see that we know the things that we need to know. The height there is, as we said, sine theta. the base of the right hand side here is obviously 1 minus the cos theta. So by Pythagoras I can say that r squared then is the sine squared plus 1 minus cos theta all squared, and that simplifies down that r squared can be expressed in terms of theta. Our area is being given to us now down here on the left hand side. It's the first area, theta, plus the second area, which is half beta r squared, and minus, and I'm giving it into the 2 bits, minus 2 of the triangular areas. In the next line we're just substituting in, and we're saying theta plus a half, and we're replacing for beta now, a half pi minus theta, and we're going to replace for r, which is going to be 2 outside of 1 minus cos theta, and we've simplified down the piece we're taking away. We know that if the total area of the circle is pi, the donkey is allowed to eat pi over 2, so pi over 2 then, down here, must be equal to a simplified version of our equation, which is just pi minus cos theta outside of pi minus theta, and we're going to be taking away a sine theta. Now clearly we can simplify that down further, and what you do know, or can see, is that a simple number answer won't fall straight out of this. So you're going to have to go for an iterative little solution on this, or you can use the modified Newton-Raphson or whatever method you like to get a solution to it. But now you know the equation. And the reason why I was happy to put in this as the second question is very often we find ourselves dealing with problems where an answer just doesn't precipitate out an actual number answer, and we are left facing iteration problems or Newton-Raphson or some other method to successively get us to a sufficiently accurate answer. In this case, if you have 3 significant places in your answer, that will do us. So have a little bit of fun with that, and we will obviously post the final answer, but I felt that you might be happier playing around with these and then finding out what the final answer is. Okay, see you tomorrow for the third problem.